I'll probably give an intro for Siddharth. So, Dr. Siddhartha Banerjee, alright. Call him Siddharth, but Dr. Siddhartha Banerjee.
Don't need to call him doctor. The Sid is fine.
So, he finished his bachelor's at IIT Kharagpur, I think industrial engineering, right? Industrial engineering. Then he did work for a little bit in India, Bangalore, Oracle Financial Services. Then he decided he wants to move here to do his PhD, right? And get really deep into the deep learning side of it. So, yeah. So he did his PhD in Penn State. His topic of his PhD is text summarization. That's what we want to talk about today. So I know him through the other forum I run. We met a few times and we exchanged a lot of notes and we do exchange a lot of notes. I bug him a lot. So I bugged him, so he said he's going to come and present here. So yeah, welcome.
Thanks, Malay. Thank you everyone for showing up. So, yeah, hello everyone. Thank you for showing up. And thanks to Malay for inviting me here for this particular talk. As you mentioned, text summarization was my area of research for the past 4 to 5 years back at Penn State. I have had some experience on a very interesting problem for generating Wikipedia articles automatically. So that's where I tried using automatic text summarization. So I'll be talking about my research a little bit, but mostly focusing on what other people have been doing in that specific area. Not going into too much technical details, but a high-level overview of what are the specific directions people have been taking. I currently work for Yahoo as a research scientist in the content platform team, and I'm focusing on a specific problem of relationship extraction, which is used in question answering kind of tasks, knowledge base expansion. So I guess Malay already covered most of it, and I just started recently working for Yahoo after I completed my PhD back in December. So this is the brief outline for the talk today. I'll cover what text summarization is, what is the overview of the work that currently exists, what people have been working on, specific challenges in this area, the current trends, what people are working right now, and what my experiences are in this specific area, and then what I personally feel that is the future of summarization, what are the specific interesting research problems that people would want to work in the near future, and then we'll have some time for questions. So text summarization, I guess all of you know what text summarization is. Basically getting a shorter version of the document that you read, or it might be a set of documents. If you're reading multiple documents, then it becomes a multi-document summarization. If it's a single document, it's a single document summarization. Now, what do you think an ideal summary should contain? Now, when you read a particular document or a set of documents, the summary should have as much information as possible within a limited amount of space. So if you are reading 10 sentences that have been retrieved from a document containing 100 sentences, you should ideally get an understanding of the entire document of those 100 sentences within just those 10 sentences. So it should be informative. It should contain all the basic information that is the essence of that entire bigger document. Another thing is coherence. So when you read a summary, it should be coherent. So an information that's, for example, you shouldn't start a sentence with a pronoun, say he was the managing director of this company, because you don't know who he is, and then that he becomes an entity like Mr. This person did this or something for this particular organization. And that's not how coherence is defined as. Coherence is you should describe an entity first and then go on to describe it as a pronoun and something like that. So it's some sort of an ordering that the sentences should obey such that the final summary is coherent. And there is also this notion of grammaticality. The sentences should be grammatical so that it does not affect the readability of the final reader. Now, there have been two broad areas of summarization that people have worked on. One is extractive, which is the more traditional form of summarization that people have been working on, researchers worked on in the past. And the other one is abstractive, which has become really famous in the last few years. Now, what does extractive do? It just extracts sentences. So think about it, if it is a news article on the recent, say, Mexico earthquake that happened, actually two of them, and then if you are trying to get a summary, probably taking the first 3 sentences of that article will give you a good enough summary, which is just picking up the raw sentences from the news article and showing it to you as the summary. And it's considerably easier, extractive summarization, because you pick sentences as is, do some sort of ranking, selection of sentences, and there is no issue with grammaticality because the sentences are picked from the actual documents. Abstractive, on the other hand, is much more difficult. It's like reading the entire document, figuring out what pieces of information are more important, assembling those information together and trying to recreate new sentences, rewrite new sentences. And there is a lot of content understanding and rewriting going on. And that's what when humans write summaries, that's what we try to do. But extractive doesn't really do that because it does some sort of like understanding in terms of ranking the sentences. So ideally, abstractive is preferred, but it's very difficult. Extractive summarization is really old. Like it started back in 1958, when a lot of us probably were not even born. And what the idea was that sentences that mention words that occur frequently in the document are more important. So you go through a document, find out the more frequent words, and figure out which sentences contain those frequent words and show maybe a top K of those sentences. And that idea has been going on in extractive summarization for the last few decades, where word statistics-based approaches such as like text rank, Sentencebased techniques were used. So in text rank is basically a modified version of the page rank algorithm, but instead of web pages, you had the concept of like single words, figured out which word co-occurred and found out a score for those words and ranked sentences based on the scores of those individual words. There were supervised techniques where training data was created by human annotators. It said, okay, in this document, these are the set of the most important sentences. And then you use some machine learning algorithms to learn those ranking of those important sentences and try them on the test data on new documents and produce summaries. One important direction of extractive summarization was when topic models were studied. So topic models basically is when you feed documents into this topic model learning algorithms, it produces a vector of values where you can represent each document or each sentence as. So each sentence becomes a vector representation with the values which are topic based. So you say that in this news articles, in this bunch of say 100 news articles, I should have say 10 topics. So each document will get then tagged as individual values for each of those topics. So it will be if it is like 10 topics or 20 topics, it will be a 10 or 20 dimensional vector for each document. And if you're doing that as a sentence, it will be at the sentence level. So you can represent each sentence as the topic vector. And then figure out if you are trying to generate a summary, if you take the average of all these sentences, you create an average topic vector and find out which all sentences are more closer to that central topic vector. And the idea is that if you get more sentences that are more central to the essence of the entire documents, you're probably going to create a better summary because you are capturing the central essence of those documents. So this talk today is not going to focus a lot on extractive summarization because I personally believe that the entire research world on summarization is moving towards abstractive. And I want to have a discussion on why I think abstractive summarization is necessary. Because extractive was also doing a job, right? You had news documents, you fed the news documents into the algorithm and it could still generate a summary. But let's consider this small example. You have 3 particular opinions on iPhone. One of them says the battery lasts long, the other says the battery is bulky, but it is cheap, and then the other says the battery is bulky, but it lasts long. So there is some redundancy in the first and the last that it lasts long, and there are like 3 different aspects I want to portray in the summary, that it's bulky, it's cheap, and it lasts long. if I try to do an extractive summarization, because every summary has some sort of like a limit to the maximum length you can have. So the extractive summarizer will pick up, say, one sentence among these three and show that this is the summary. Because of that limit in summary length, I lose some information, right? I say it lasts long, but I do not include information about its bulkiness or the fact that it is cheap. In case of abstractive summarization, ideally I should be able to do that, but within the same length. And if you see this output, it says the iPhone's battery lasts long and is cheap, but is bulky. It probably uses almost the same number of words as the extractive summary, but includes almost all the important information that was included in the original opinions. But as you can guess, this is really hard to accomplish because a lot of language understanding needs to go on. But some user studies in the past have shown that this is a more preferred form of summarization than extractive. Now, when did abstractive summarization start? Abstractive summarization started at a sentence level back in like 2008, 2009. People were trying techniques on sentence compression. So if you are given a bigger sentence, it said that, okay, return me a sentence that still retains the essence of the original sentence but throws out certain words. So based on some optimization techniques, language models, it figured out, okay, if I threw out with her from this sentence, if I did not include but a month ago, I can still retain the original essence of the sentence, mostly the important information. But some research also showed that you are just trying to remove certain words from the original sentences doesn't necessarily mean that it will result in a good enough summarization quality. And also it is at a sentence level. So summaries are generally considered to be a bunch of sentences and not just single sentences. You can create a compressed sentence using sentence compression, but you cannot create a compressed document with this sort of techniques because it is at a sentence level. The other direction that people took was template based. So template based is you have a particular domain, say if it is a medical domain, you ask humans to generate certain templates, extract information from those documents and fill in those templates to create a summary. Now this actually works very well, but it's restricted to particular domains because it requires a lot of manual effort to create those templates. So you can ask a lot of domain experts to sit and write templates for a particular use case, but they cannot be transferred into a different domain. Any issues? Can people over the phone?
That's what
hear me? Oh.
They haven't dialed in. We're trying to dial in. Just give me 1 second.
Okay. Yeah.
Sorry for that.
Yeah.
So what are some examples of domain based? Like, which are they being used? So what are some live?
So,
Apart from user.
one of the things, like I read some papers on medical summarization where you have, say, patient records, there were multiple records, and if there is a template, okay, this person was suffering from, that stays pretty standard. But based on the information that you can extract, like doing some sort of sequence tagging where you identify that this was the disease that the person was suffering from, you fill that information in that blank. So the sort of the template for a person, for patient suffering stay the same, but the values depend upon particular patients. So the template stays the same, but you can use it. But it's very restricted, right, for a particular domain. You cannot use that for a person who may be like getting into something else. It's like you can't extend that easily to something like a meeting summarizations. So it's not easily extendable.
So the manual effort is basically because you have to create.
Yeah, and you need domain experts, right, to create those, like what kind of a summary you want, or maybe a doctor wants, so that it's properly understandable. So. But they have been found to work well. So if you're thinking about a really restricted domain, I think it might actually work well.
So there is a package in Jensen, right, to do summarization. Does that fall under abstractive or?
No, it's I think just plain extractive. They have like text rank implementation, and text rank actually works pretty well with new sort of documents because you find out word statistics and use the word statistics to rank the sentences. In case of news articles, I think if you maybe even do a pre-processing with simple like part of speech tags, include the nouns, weigh them higher, you can still get a very reasonable sum.
But what about coherence? Like, coherence seems to be a bigger issue.
Coherence is a very big issue, and in single document summarization, it's not really that difficult because you can keep the same ordering as the order of the sentences in the original document. But in case of multiple documents, it's really difficult.
Okay. So single document is the multiple document.
Yeah. And it's just the notion is mostly about ordering. Like if you can order them correctly, and you have the connecting bits and pieces of the information that you mentioned in the second sentence. If there is some reference there, that should ideally be there in sentences before that.
So are you providing a weightage to each word and which is more of a weightage?
So that is like most extractive summarization algorithms use that, not the topic-based form because they figured out the topic. I mean, it's still frequencies of words based, and that's how they compute those topics for
That's not frequency, where the weightage of a word, because somebody with a strong language which has written, it would have the weight would be more higher, right?
Yes, so I mean,
When they say, like we need to leave a domain pivot, just to make sure the summarization is actually right. So can you list down like what are the activities that goes as part of the customization of particular domain?
sure, I can like talk about it. I don't have like slides on that.
Yeah, that's fine.
Yeah.
Just so that he has to
I will answer his question first
Right,
on, and I think that could also relate to what you were asking. So as I was saying, like I worked on something which is like Twitter-based summarization. So the problem was you have these humanitarian organizations who work during disaster events, and information in Twitter actually propagates really fast. And if you can use the tweets to generate a summary for those humanitarian organizations, they can take action as soon as possible. So there, what the humanitarian organizations they mentioned was that words that are mostly like content words, they describe some set of like content words such as people need water. So water is something important, you should weigh them higher or something like that. Or people need a place to stay, shelter and things like that. So if you have those keywords, which might be domain specific, try to weigh them higher in sentences and then try to create a summary. Those summaries for domain specific nature works really well. So it's not always frequency based or words, how you compare the how you compute the statistics, but it's more about inducing some sort of a domain knowledge to bias the summaries to something that people actually need. To answer your question, I think in some cases creating templates is what I mentioned. So you create templates, reading a lot of summaries of people, like reading a lot of cases and think what things should actually go to a summary. So if you are a summarization expert, not really a doctor or a physician, you might actually want to go and talk to a physician and say which all things you would want to be there in a patient summary. Right. And then trying to figure out, okay, these are the aspects. And there are different techniques of like aspect-based summarization. So you have patients, maybe what was say the triglyceride level at that point. Those should stay as one important indicator for this particular class of patients because people of these demographics have been found to suffer from something which can be associated with triglyceride. So I think a lot goes into determining what is important for that particular use case. So talking with domain experts is really important. Yeah. So yeah, no problem. So and as you know, current trends. Sorry. Can people hear on the phone?
Hey, can you guys hear on the phone? Is it audible?
Yeah. Yeah. So going into the current trends of summarization, and as you might have all heard about the buzzword deep learning, everybody talks about it these days. So that also caught up with summarization at some point in the last few years, and people tried using a lot of techniques for summarization. Mostly it started off as sentence-based, similar to sentence completion, where you are given the first sentence of a news article, try to predict the headline of a news article. And it's very easy to get data for this, right? You can crawl as many news articles as possible, take the first sentence and take the title and train the models. So, which in contrast to regular summarization, like multi-document summarization, it's very hard to get the data. Because even if you get like 10 news articles, you need a human to actually go and write those summaries. And it's very time consuming. And it's difficult, like even for humans, reading like 5 to 10 documents on the same topic, identifying what's important, is very difficult. So, this particular technique was, the first one was based out of like a simple feed-forward neural network technique, and then the same team from Facebook AI Research, they followed up with a recurrent neural network based technique, where recurrent neural network is very efficient in modeling sequence as well. So that worked much better than the first version they had.
So, good question there.
Yeah.
Newspapers, yeah, it's very easy, right? Like, you have a headline, you have like news article.
Yeah.
And if you have the scientific papers, you have abstract. Then you have like a.
So a lot of summarization has been done, like especially a group from Michigan, University of Michigan. Dragomir Radev is that professor. His group actually worked a lot on abstract generation from like scientific papers, but it's mostly extractive as of now. So they do some sort of like, because in an abstract, if you see an abstract of a scientific paper, it's still structured in a way that you introduce the problem, then you have some sort of what approach you use, and then go on to something on the results and then conclude. So they took some segments of that paper, identify the introduction, match that, align that with the first or 2 sentences or something like that. So yes, there is work in that area also. Now, then something like really nice happened in this area of RNNs is sequence-to-sequence models, which was originally formulated for machine translation. So you have, say, this ABC is English, and this WXY is WXY. US basically is the end of sentence. So WXY is the a different language, maybe German. Yeah, whatever. So the sequence-to-sequence model, what it does is, it reads the English, creates an intermediate representation, and for learning this, it uses some RNN, modified form of RNN. There are some latest different types of recurrent neural network cells known as long short-term memory or gated recurrent units. So people use this, get an intermediate representation, and then start decoding to predict what are the translated words in a different language. So how do you learn it? You have training data, and a lot of training data is actually available for machine translation. So you have aligned sentences from English, French, German, and so on. So how it was modeled was, you basically take the log probability of a translation given the source, and during translation you maximize the translation given the source and see what is giving you the maximum confidence or the probability in terms of decoding. And this thing is actually very applicable to summarization at a sentence level if you think about it. You have a sentence, maybe the first sentence of a news article, and you try to predict the headline. And people actually used it and got very, very like good results compared to previous approaches for the same problem. And then people started going into more deep about RNNs with attention models. So attention is a concept that whenever we are reading some book, we try to understand, okay, this part of the page is more important, the others not so much. So attention is the same concept that some portions of the sentence are more important than others, and they should be weighted higher than the other parts of the sentence. So this particular work is very recent from the Stanford NLP group. They, sorry, okay. So they are trying to formulate they are trying to address the same problem of generating a headline based on the first sentence. But they also realized that there is a problem here. If you are doing the sequence to sequence problem, some words such as, if it is like Germany emerged victorious in 2-0, this 2-0 might be a very rare word in the vocabulary. So understanding its proper representation is difficult. So why don't we try to copy this word from the source to the destination without worrying much about whether it is present in the final vocabulary set or not. And what they did was they modified this model with an extra probability generation stage, where this generative probability tries to figure out how much of the weight should I give to the original vocabulary and how much of it should I try to copy from the original sequence. And this is really interesting. Germany beat Argentina and it can just copy maybe 2-0, which was not even there in the original vocabulary of most frequent words. For more details, you can obviously go to the paper. I won't go to the deep level mathematical understanding, but it's a very interesting work that has come, and I think they also have the source code available, so if you're going to try out, you can.
Was it from Software Group?
No, this is from Christopher Manning's group, a guy called Abigail.
The point networks are very interesting.
Yes, yes.
So generally you tend to use, for a machine translation, typically what happens is you have pretty much the same sentence length for like your source and target.
Yeah.
But summarization is not that way.
Yeah.
Summarization, you have like so much difference in the sentence code. So point networks actually tend to work better for these kind of problems.
Yeah, but I mean, most of the summarization that still that works with deep learning are still at a sentence level, like with a headline generation task where the data is easily generatable, like the training data. There is the problem with evaluation also in summarization. So as I said, even when a human writes a summary, it's difficult. But how are we going to judge how good that summary is using some automatic means? There is some technique called Rouge, which is used in all the papers for summarization on standard datasets. What it basically does is you have a ground truth summary. Say if you have 10 different documents and you have a ground truth summary which some human has written. So you figure out, and if you generate a system generated summary with whatever algorithms, and you compare the summaries the human has generated and your system generated, and how you compare is with n-gram overlap. So Rouge 1 is basically finding out what are the common words among both the summaries and give a score, which probably doesn't make any sense because you can have the words here and there and anywhere in the document. They don't need to be any coherent sentences, but still your root score can be high. It works reasonably well if you consider extractive summaries because you are sure that they are grammatical, but for abstractive summaries, it's difficult to judge them by root scores, but still people have to report it because it kind of has shown that there is some correlation to human judgment scores with the root scores. But I personally believe that it's no way close to what automatic evaluation for summarization needs to be. And obviously for abstractive summarization, manual evaluation needs to be there, some sort of judgments from human individuals as to how good you think the summaries are. So you generate a summary with some algorithm and then ask people to rate based on what do you think is the information quality is, how good is the readability and the coherence, things like that. There are multiple different data sets. So one of the news article based data set that I used was the DOC or DUC, normally called as DUC, and now it has become Text Analysis Conference. Earlier it was Document Understanding Conference, and they usually have a lot of data sets. So you might have sets of like 50 different document sets. Each topic will have say 10 documents, 8 to 10 documents. You will have abstractive summaries written by like 3 or 4 different human individuals. So it's pretty comprehensive data set if you are trying some sort of summarization techniques, new techniques. And there are other data sets based on like meeting conversations. I already spoke about headline based summarization tasks, and there are corresponding data sets for those too. Meeting conversation is particularly very challenging because if you think about news, the language is very formal, but meetings, you might be abusive to some person, or you might say something on a very informal tone. Okay, shut up, let's go to this particular task. How are you going to summarize all that? And the quality of the abstractive summaries, when you read the abstractive summaries for meetings and the actual meeting conversation, they are so different. And I personally think like meeting conversation is a very, very difficult task to accomplish. Probably templates, like people have worked using templates and it has worked somewhat better than the traditional extractive or somewhat abstractive summarization techniques from the dialogues.
A lot of guys are trying to do that by Zoom and
yeah.
Just one other automation.
Yeah, I think if you like the template-based thing might actually work really well because if you are having similar kind of meetings every day, create templates and extract the relevant information and just fill in there, it might be a good direction to try. Now, as I spoke earlier, I work on summarization, but from a very application-oriented perspective. I started working on a problem which was to automatically author content for Wikipedia. So I was trying to generate content for Wikipedia articles automatically. And I was trying to tackle two different problems. So you have some articles on Wikipedia which are very short, which do not have comprehensive information. I was trying to see if the web has information on that article, why don't I go fetch it and then summarize it and put it and expand those articles. And also constructing new articles. There are like 700, 800 articles getting added to Wikipedia every day, but there's still a huge backlog of articles that people want to have a place on Wikipedia, but there's no one to actually go and write those articles. So can I actually use a machine to do some part of that task? May not be 100% accurate, but at least help the current authors. So it had like various steps, but summarization is what I'll be talking about mostly. So, although like deep learning had become pretty popular around like 2014, 2015 when I was working on these problems, but for my particular use case, there were like a lot of different problems that the deep learning algorithms couldn't really solve. For example, one of them was the most important techniques of deep learning that people had been working on were mostly based on sentence level, and I was mostly trying to assimilate information from multiple sources and then somehow using information from all those sources to create new sentences. There is this problem of unknown words that existed in deep learning, which this current paper is trying to solve partially, as I just explained, like copying words from the source to destination. But still, it's not foolproof. So if I try to even experiment with a bare minimum number of articles on Wikipedia, I should at least have some reasonable content that I have summarized and not throw something like unknown word onto Wikipedia, and they wouldn't like it. So I figured out that one of the ways to maybe tackle this problem is trying to use fusion, fusing information from multiple different sentences and trying to see what information should be retained and what should be thrown out. Now, one particular example is this, that there are 3 different sentences about a particular outbreak that happened in North America. I create a graph of words with the dummy start and the dummy end node, and all these words are basically the words along with their part of speech tags. I don't show the part of speech tags here for clarity. Now, because these sentences have some common words, it's likely that there is some overlapping information which you can connect. So if you think about the outbreak as the common word between these 2 sentences, you can create a new sentence that says enterovirus D68 cause outbreak is the largest ever reported in North America. So that's one of the sentences that I get using this graph, because you can just traverse from the words, from the common words, and create new sentences. Now this is a very small example. If you have multiple different sources of information, ideally there will be a lot of redundancy in those web pages, and when you collect those information, get similar kind of sentences, cluster them together, and you can actually generate many new sentences. Now the problem comes, which sentences should I select? So the problem is now kind of a over-generate and select strategy, that you have so many generated sentences from the word graph, and you can select only a few because there is a limit to the summary length. You can't include all sentences. And also there is this concept of redundancy, because you cannot include you cannot write the same information in the second and the third and the fourth sentence. You just want to include that once so that the summary readability is enhanced. So the concept what I used is, like earlier I talked about these three factors. Why don't I try to use all these three factors together and try to select the best set of possible sentences from the sentences that I generated using the word. Now there are some formulas here. If you don't understand, it's fine. I'll try to explain, but the concepts are pretty simple, that I am trying to maximize the overall quality of the summary considering the informativeness, the linguistic quality, and also the coherence together. So if we consider the three, say I generated three sentences, P1, P2 and P3, and I can select maybe maximum of like 2 sentences given their lengths within that summary. So which 2 should I select? So I can judge the importances of the sentences based on certain metrics. Let's just call it information coverage. I use text rank for that because it worked pretty well for my case. You can use any other scoring techniques for sentences. I use the language model to score a sentence as to how probable linguistically it is, basically the sequences of words. And there also you can use any other language scoring techniques, like for example the Stanford Core NLP. When you parse a sentence, it can give you a confidence score as to how probable this sentence is based on the sequence of words as well as the dependency parse. And here is this concept of coherence. Now the coherence, how I try to model it is, if you consider any 2 sentences, they can have 2 different orders. You can have sentence 1 first, sentence 2 second, and you can have sentence 2 in the first place and then sentence 1 in the second. Now how do you judge the order? So I judge the order based on certain like arcs that I introduced in this model. Is there a question? Okay. So based on the arcs, finally I am supposed to figure out which arc should I retain. So between, say if I have to choose one specific order between P1 and P3, I can just select arc 1, 3 or arc 3, 1. And this boils down to an optimization problem where I can select only either these can be just binary variables, either a 0 or a 1. And that's what this entire problem formulation does. Formulated as an integer linear programming problem, select finally the sentences and the arcs simultaneously so that you do not consider the importances of the sentence once and then try to rank them, because it might be possible that if you select those 2 sentences, they cannot have any natural order on their own. So it might be that you select 2 sentences out of 5 sentences, and no matter how you place them, they will not be coherent in any of those ways. So that's why the joint optimization, the idea was to use this joint optimization such that the overall coherence, the informativeness, the linguistic quality all are tackled together. Is anyone interested to go into details of the mathematical formulation, or can I skip it for now? Or maybe you can talk later if you have questions. Okay. Yeah, too much maths.
So just one word on coherence. Like, what is it that you put into this equation or any way to understand the coherence? Like, information and linguistic is still easy to understand.
Yes, so for this particular case, if you consider any, say, news document or Wikipedia article, you assume that it is coherent. If you take that as a training data, you can learn features from adjacent sentences and say, okay, like if you maintain that order, it's coherent. If you are formulating, say, a classification problem, if you can take 2 sentences, 1 and then maybe like sentence number 4, you can say they are coherent because they are in this particular order. But what if you reverse them, then they probably won't be. So doing some sort of a negative sampling on that article at a sentence level. So that is the idea I have used, taking the original actual documents as the training data. Features, you can use a lot of features, like I use some sort of probability based features, like how many common words you have, what is the probability that there is a jump from sentence 1 to sentence 2, like with sequences of certain types of nouns and verbs in sentence 1, then the nouns and verbs in sentence 2, how probable is the jump from sentence 1 to sentence 2. So kind of probabilistic notion of how coherent it is, getting a number between 0 and 1 and then using that in equations. So there are multiple ways of doing it. So these are some of the results on the data sets, and these were some of my systems which kind of worked slightly better based on the root scores. And again, like mine was abstractive, so all the rules work better. You cannot really say they're the best performing because language is a critical problem. So we got some annual evaluation done, and we found that actually people, like we asked 10 evaluators on Crowdflower platform, how do you think is the information comparing these two summaries? We randomize the summary order so that there is no bias. And according to the numbers, it seemed that there is like a 5% improvement over the best extractive summary. So people thought that a lot more information is being conveyed within that same amount of space. We had a summary length restriction of around 100 words. And readability wise, there was a reduction, which is kind of obvious because I'm trying to merge sentences and not always, like if you have 5 different sentences which are grammatically not correct, the language model will still score them. And one of them will be higher than the others, but it still doesn't mean that it is grammatically correct. So maybe using a binary classifier to judge whether this is grammatical or not probably would have been better. But again, that might have reduced the coverage of the information because in a lot of cases the algorithm might have thought that okay, this is not grammatical at all. So there are a lot of trade-offs. Particular error cases which I found really interesting was repeatability of information. So when fusing information from multiple sentences, probably it found killed 270 people, and then 270 people killed was belonging to a different sentence. So it got merged together, and the same killed and killed got repeated twice. Maybe doing some sort of like a coverage understanding as to how much, what information you have included till now, or using some sort of a incremental parsing kind of at every stage to figure out whether including this is important or not would have made sense. The Twitter-based summarization that I spoke about earlier, we had something like a concept of content words and basically weight content words higher, and that was the only modification. And it actually worked pretty well in terms of the readability also, because Twitter, if you read tweets, they are so informal, and a lot of tweets have language problems, even in the raw tweets. When people write, say anything, there might be grammatical errors, there might be spelling errors, and so on. So when we merged information from these multiple tweets, this was our technique, and based on readability, we still fared as good or slightly better in certain cases, certain classes of tweets than the other comparable methods. And one of them was an abstractive summarization technique as well. So people did prefer our summaries, and when we talked to this humanitarian organizations that work on like crisis management, they actually found that pretty informative and said that these are actually very actionable summaries that you guys are generating. So they were planning at that point to use that for the future with some changes. So the work is still going on. I'm not a part of it right now.
So when you use like a differency parser, right, for a language written well, it tend to fail you. So how do you do it for Twitter?
We did not use a dependency parse here. We just use language model to score the final generated content. So it was just sequences of words, not a parse score. But there are Twitter specific dependency parser that you can use. CMU has one, which is very famous. We have been using it. So yeah, that actually works pretty well on tweets. And especially they have, so the standard part of speech tags, they don't exist in Twitter. They are like very different because you have emoticons, you have dot dot dots. So everything is spanned out as different part of speech tags.
In one language by itself.
Yes. So they had annotated data, and it was like it has around 80% accuracy, which is reasonably well considering how bad Twitter data can be.
Yeah. So my question was slightly non-mathematical, right?
Yeah.
Twitter example you're giving. So let's say there is some humanitarian crisis happening somewhere in the world, and Twitter is like getting a lot more tweets on that, right? So does this work on real time? I'm not saying every tweet you have to summarize, but like micro batches, right?
So
probably every 10 minutes you do it and summarize.
Yeah, so I mean, obviously a lot of these experiments that we did was offline.
Okay.
But we kind of tried to figure out how fast this algorithm works compared to the others, and we were almost similar to extractive,
Okay.
like not any slower. And extractive summarization generally works pretty fast because there are like fast feature generation and then ranking if you're thinking about machine learning based techniques. And we did not try it on a real system at that point, but I think it could be done. Not like every say 10 minutes, 15 minutes, you can generate a summary and see what's going on and try to generate take action from those specific aspects. So this was a meeting summarization task that I worked on, but it was kind of similar to like a word graph based, but I used like dependency parts of the conversations and try to figure out what portions are important. And it's kind of very similar to the word graph based approach that I used on news articles. Now, as I mentioned, meeting conversations are very difficult, like how people talk informally and all. Although we got better root scores than other abstractive systems, but when we tried to do readability analysis, we found that only probably about like 30 to 35% of the generated summaries actually read like a summary. The rest are pretty junk, and that was mostly because if you are trying dependency parser around conversations, it doesn't work well. So the error propagates down to the most like the last level of summary generation. And here was one interesting example though that we got. I generated something like it was voice activated and human written summary said was included to add speech recognition. So it was kind of like similar, but with Rouge it's very hard to figure out that they are the same thing, right? You don't match words, but still you are talking about kind of the same aspect. So this again shows how difficult it is to automatically evaluate summarization. I have summarized a few resources for summarization, which I think you might find it useful if you're trying to think about like using summarization in some of your problems. You can start off with like the most basic extractive summarization techniques. Very easy to use the libraries, like just one-liner in Python, feed in the document. For the headline generation task, this is also an interesting library, but they don't have the supporting data because that's copyrighted the gigawatt corpus. But if you have access to it, it's good enough, or you can crawl your own data from these websites and create a data set. And TensorFlow, which is one of the most famous deep learning libraries, frameworks now, has a summarization module which uses the sequence-to-sequence models.
And actually train on gigahertz, right?
Yes. So mostly, like if you are thinking about large-scale training for headline generation, I think gigawatt you can just extract the first sentence. But if you have enough resources to crawl data, I think that also works as well. And yeah, so one of my forks of the abstractive text summarization techniques that I developed also on GitHub. So if you want to try those, you could.
Did you do anything on preference tweets?
No, I did not. A lot of people were doing like character level generation of new tweets, learning tweets and generating tweets.
You don't need text summarization.
No, I think there's a guy from MIT who did that, right?
Yeah. It was pretty good actually.
Last 2 years, take it, and then you will get the fire.
No, I mean, like, see, the problem with the natural language generations, right? I think it probably works well for Trump and tweets, but for others, right, you can't make it really coherent. That becomes an issue.
Trump is actually very coherent because he always speaks like stupid. It doesn't make sense, like the sequences. So that learning is actually working well.
Yeah.
There is no variability.
Exactly. The otherwise it becomes extremely tough to learn that thing. Natural language generation has not been cracked yet. Like, a lot of people have been working on it. It's very difficult to, like, you can generate it, you can make it look like as it's coherent, but it's not.
I think like summarization is very far from being solved. People are trying a lot of different techniques. Content understanding still remains a huge problem, and it's a very important problem that needs to be solved because the amount of data that's growing day by day is being used for automatic authoring in journalism. Like there is a company called, I think it's called Narrative Science. They're based out of, I think, Boston or Chicago, yeah. And they are trying to do some sort of like automatic journalism. You have facts and try to feed in those facts, generate articles. A lot of the work they are doing was template based about a year back. I don't know what they're up to now. But yes, I mean the importance of summarization is like it can be used in several different domains, and a lot of impact can be caused by improving summarization. Deep learning for summarization has been going past few years, and I personally think it still has a long way to go. New models are coming, sequence to sequence seem to work really well on the headline generation task. But what about multiple documents where summarization is really important? Or even like a set of records in say a patient records, you want to generate a summary, it's still multiple documents because it is different stages of a patient getting cured from a physician. So you want to get as many aspects possible and create a comprehensive summary. So those techniques still have to evolve, and Rouge as an evaluation technique, I don't think that's good enough, and people need to also figure out how to automatically evaluate summaries. Because you can't really always ask people to evaluate on Crowdflower or Amazon Mechanical Turk because you don't really know how good they are, how the quality is. And you cannot also ask your colleagues or employees to always keep evaluating summaries. And because you keep improving an algorithm, and at every iteration, if you ask a colleague to evaluate, they'll probably not talk to you from the next day. So I think that's why evaluation techniques are very important, and I haven't really seen much work happening there. Rouge is still getting used, which somewhat gives you an initial indication as to how informative it is, but nothing much into like the coherence or readability and things like that. And like overall, summarization needs to go to how we visualize summaries, like reading the documents, organizing the information, the aspects of information, and placing it in a way that aspect 1 should not be dependent on aspect 2 on that summary, and they should be different. So that's where I think most of the effort that needs to go. And these are my personal opinions, might not be for others, but this is what I think after having worked for a reasonable period of time. These are some of my publications. If you want to go into like details of the mathematical aspects, the formulations, the Twitter-based summarization paper is actually pretty interesting, and a lot of people are like citing it now because social media summarization is really a hot topic now.
What citations you got so far?
That it's just like around maybe 15 or 20 since like last year, but it's a relatively new paper, yeah.
Any question and answers from the telephone section?
I had a good question.
Mm-hmm. Hi, yeah, please.
I want to know if ontologies and RDFs or any of those knowledge representation type of data sets can they be incorporated into summarization techniques?
I don't know much about using like those sort of like. Do you mean like triplets based some information of that sort?
Exactly.
Yeah.
So we have a lot of domain, a lot of domain specific understanding of, let's say we are working in a specific domain.
Mm-hmm.
There could be knowledge representation in the form of triplets.
Yeah.
Which could be utilized to add some more coherence to summarization.
Mm-hmm.
But have you seen anything like that being utilized?
I think that's a very interesting question, and I don't know of any. There might be some work. I don't know of any, but just thinking about it quickly, I think one of the ways you could probably try to do that is aligning some sentences. So, For example, like in relationship extraction, you have sentences and you can align triples. So in the same way, if you extract triples, try to generate the sentences from those for summarization might be doable. So directly not from the knowledge base, but getting a corpus, aligning that to a knowledge base, then learning some sort of like information extraction in the form of triplets and translating that to a sentence, formulating somewhat similar to a sequence to sequence. So a multi-step process, but I think that might be a very interesting direction.
Okay, thank you.
The Wikipedia use case, is it like actively used?
No. So I mean, we cannot really go ahead and put a lot of like information on Wikipedia just like that. Wikipedia doesn't allow bots to go and enter data. So we did like small experiments. We added around like 40-50 articles, saw that how much of the content is getting retained and all. So we had fairly about like 40-45% of the content that was retained at that time. So it wasn't a huge success, but somewhat towards that direction.
Another problem with general summarization, if you're doing from the internet, is you don't know what everything is said is correct or true or verifiable.
Yeah.
So putting in
That was a very important problem for Wikipedia itself because you don't know the reliability. So one crude way of doing it is take the domains that have been already mentioned on Wikipedia and assume that people have already reviewed it, so they are reasonable domains to take information from. So if only those domains you are taking information from, so you can use those information sources. So if a domain is not there, then it's a problem, but you can learn somewhat features to identify reliable sources. And this is very important because we tried generating some articles in the domain of like diseases and disorders, like adding some content. And you cannot, like, they're very important sensitive information, right? If you put a wrong information about some medicine or something, it's bad. People read it and it's bad. So it's very important to judge the reliability in those cases. So we had a human to actually go and read that no crappy information is going into it. And yes, we did all the steps just as to ensure somewhat reliability, but that was not a part of the modeling that I did. But I think there are some researchers who worked on reliability analysis for websites.
But I think regardless of the use case, manual intervention at the end of the day has to be there.
Yeah, so in Wikipedia, so in Wikipedia, like if I go and enter some content, there will be a reviewer who is a more important contributor who has contributed and he has attained that level, so he'll go judge, decide what has to be thrown out and what has to be modified. And maybe it might come back to him. So in few cases where we entered data, it was not grammatical and they asked us, please change the grammaticality because it doesn't sound good. And which was fine, like we did those changes.
Another question I had is, obviously all of this work is done on the English language as such, right, all the summarization. And English language itself is very fuzzy. I'm just thinking maybe there is another language in the world which is less fuzzier. It might be easier to do summarization in terms of coherence or something like that. I'm just trying to think that, is somebody trying in other languages and especially, convert English to some other language and convert it back from the summarization. Might be better somebody.
Yeah, there was a work happened on Sanskrit language. Sanskrit language is very much grammatical, and this work being done by DOD, not at DOD, Defense of Defense Research of India, DRDO or something like that. Yeah. So they found that Sanskrit is very much language, but Sanskrit nobody is using, right?
Exactly. So you still want a language which is the natural representation of it. So I'm just thinking converted, like we had that sentence, right? Killed 270 people, were killed. Things like that will go out once you actually have a better language.
So I think what you are implying it's mostly on like sentence level coherence.
Yeah.
So there is a bigger problem of like inter-sentence coherence, like how do you order those sentences? And that problem still stays no matter what language, like what aspect you are talking about. You don't want to mention that aspect like in the fifth sentence when you have already talked about it in the first by mentioning a pronoun or something. That is not.
And in another way to think about it is, anyways, deep learning language is a language in itself. It's actually creating a model which is probably a language in itself. So it's already taking care of some of the language problems.
But that's different, right? From a coherence perspective, still you See, even for extractive model, the deep learning side of things, what happens is you generate a representation, but still you have to come up with, you have to pretty much generate that new thing altogether. So the coherence issue will come. Even sequence to sequence, right? You can do a lot of stuff with sequence to sequence, but the problem is, right, you try to do anything of that nature, keep your fingers crossed, it's not going to be coherent. You can come up with something or the other.
But that way, like machine translation is a much easier problem if you think, like because it's one sentence to one sentence.
Yeah.
You write the sentences in the same order, so you basically are translating it always sentence to sentence. So sequence to sequence actually work very well for translation, but not really that great if you consider like multiple sentences. And I tried it out during my PhD, like combining, like say the top 5 sentences, take the representation of all those 5 sentences and try to generate a summary of those. And it doesn't really, like, it's very hard to control sequence to sequence.
So any other
I
questions?
do that.
Yeah.
Hi.
This is Satya. Thank you for doing this really interesting presentation. My question is, in your experience, did you find any better performance with unsupervised learning versus supervised, like text ranking versus key extraction and methods like that?
So I did not really go to a generally like a supervised dimension because I was taking like content from different web sources and had to use some sort of a ranking module, and I did not concentrate much on the informativeness component, and I reused something that already existed, and text rank worked fairly okay given the root scores and the manual evaluation. But I think if you are doing something very domain specific, I think going a supervised way, like asking annotators, given this like the document, which sentences do you think are the most important? Rank them based on your order of preference. That sort of ranking is very important in a document, like in a domain specific case, where the algorithm can learn to rank. So you can use some sort of ranking algorithms to learn based on the features how they should be ranked. So that's where I think such sort of supervised ranking approaches work much better.
Right. No, I definitely see your point. Thank you.
Any other questions on the phone?